Welcome to my OpenCV course for beginners. OpenCV is one of the most widely used computer vision and image processing library out there. Whether you are a beginner or someone who is familiar with Python, this course will teach you how to handle images and video files programmatically. In this course, first I will introduce you to OpenCV. I'll teach you what OpenCV is, the key features of OpenCV, why you need to use OpenCV, and also I'll take you through how to install OpenCV. Furthermore, this course is divided into 6 different modules. In module 1, we'll look at how to work with images, okay? Where I'll teach you how to read in images, resize images, and perform all different manipulations with images. In the second module, we'll take one step ahead where we'll look at how to draw several shapes on image files. Then in module 3, where things will get more interesting, we'll look at how to work with the video file, how to read in video file, how to get our real feed from the webcam and work with it. Module 4, we'll look at image transformations, okay? Getting into module 5, we'll look at how to blur and detect edges in image. Then module 6 being the final module, we'll look at how to detect objects, okay? So we'll be looking at what object detection is and how to perform object detection using OpenCV. Trust me, you're going to learn a lot in this course, so let's get started. Alright, so before we get started, I know you'll be asking, what is OpenCV? So OpenCV stands for Open Source Computer Vision Library. It's open source because you can use it for free. You don't have to pay anything, okay? So the OpenCV library is an open source computer vision and machine learning library designed to help developers process images and videos efficiently. It provides tools for image processing, object detection, motion tracking, facial recognition, and more. Let's look at some of the key features of OpenCV. So OpenCV can help you in image processing. That is to say, it can help you to manipulate images. And talking about manipulation of images, we can resize image, we can crop image, we can blur image, and there are a lot of things we can do with OpenCV when it comes to image processing. OpenCV can also help you to perform some computer vision tasks, okay? It can help you to detect faces, objects, and edges in images. And we'll learn how to do all of this in this course. OpenCV can help you in machine learning. So we have built-in classifiers for object recognition in OpenCV, which you can use to complete some machine learning tasks. When it comes to video processing, OpenCV is key because it can help you to work with videos and what your feeds coming from your webcam. That means you can take your live video from your webcam and process this video using the OpenCV library, and we'll be covering all of this in this mini course. Finally, OpenCV can help you with deep learning integrations, which works with TensorFlow, PyTorch, and Onis. Okay, so OpenCV supports all of these particular frameworks, so it's very easy and flexible for you to use OpenCV, and I think it's very nice if you learn OpenCV to help you a lot in your computer vision or AI journey. All right, so before you ask why use OpenCV, here are 4 reasons why you need to use OpenCV. OpenCV is fast and optimized because it's written in C++ but provides easy Python bindings. That will say you can use it in Python as well, but originally OpenCV is written in C++. OpenCV is open source and free. Everyone at all across this globe can use OpenCV. It's free. You will not be charged for that because it's actively maintained and widely used. OpenCV works on Windows, Mac, Linux, Android, and iOS. So it works on most of these popular operating systems. So there is no need to worry when you are using OpenCV. Real-world applications. OpenCV is used in self-driving cars, surveillance, medical imaging. With OpenCV, you are cool to go. You can build projects in any of these particular scope. Now that we've learned about what OpenCV is, let's go ahead and learn how we can install OpenCV and start getting our hands dirty with code. Alright, so before we proceed, I expect you've already installed Python and Visual Studio Code. In case you have not, just follow any tutorial that teaches you how to install Python and Visual Studio Code, and I think these tutorials are very common to find on YouTube. So on my desktop, I have a folder here called OpenCV, and when I open this folder, I have some images, video files we'll be playing with using the OpenCV library. So what I'll do is to drag and drop this particular folder into Visual Studio Code, and this is going to open Visual Studio Code for me. All right, so you can see I have my files right here. So the first thing to do is to open my terminal, click on new terminal, and we are going to first create a virtual environment so that we can install our dependencies in that particular virtual environment. In future, we don't want to have conflict between packages. So if you want to know more about how to create virtual environment and why it matters, I have a tutorial on that. It's on the channel, so you can just search it up, or I'll put it in this particular video description. So to create a virtual environment is pretty simple. Just type Python, that's if I can spell Python correctly, -m, and you type venv and the name of the virtual environment you want to create. So I'll call this virtual environment tech, and I'll just hit enter on this. So this will go ahead and create the virtual environment for you, and you can see we have the tech right here. So the virtual environment is created. So let's wait for it to finish. Okay, so it's finished, and the next thing we can do is to activate this virtual environment. So after creating a virtual environment, you have to activate it, and to activate it is very easy. So type tech script activate, and then you hit enter on this, and this is going to activate your virtual environment. And one thing to know is that when your virtual environment is activated, you will see the name of your virtual environment in the parentheses here, okay, in this particular color. So now that we know our virtual environment is created and activated, I'll clear the terminal and we'll go ahead and install OpenCV. So to install OpenCV, just type pip install, and then you type OpenCV-Python. You hit enter on this, and this will go ahead and install OpenCV for you. So guys, make sure you follow this exact process so that you don't run into any error. In case you run into errors, don't hesitate to put it in the comment section. So OpenCV is installing, and then we'll give it some time for it to install, and I'll catch up with you after the installation. Alright guys, so OpenCV have installed successfully, and we are ready to go. You can see we have some errors here. New release of pip is available, and if you want to install the new release, you can copy this particular code. You can copy this, repaste it, and hit enter in order to upgrade pip. But in case you don't want to do it, this is not going to stop anything or prevent you from continuing this particular course, but you can just do it if you want to. All right, the next thing to do is to create a Python file. So I'll click here and just name this file. I'll call it main.py. Okay, so main.py. You can give it any name you want, but make sure you have the .py extension at the end of it. All right, so we've created our Python file, and in module 1, we'll learn how to read in images, resize images, convert images to grayscale, and more. So first, let's go ahead and import OpenCV. So to import OpenCV, just write import and type CV2. So just like this, and you have successfully imported OpenCV. So you write import and CV2. All right. So that's all you need to import OpenCV. All right. I'll comment this so that you guys can easily understand. And over here, what I'll write is loading and displaying image. All right, so this is the comment, loading and displaying image. So everything we'll be doing under this will be about loading and displaying image. So to load an image, let's first call it image. Okay, so we call it an image, and then this is equal to, we'll use an OpenCV function to load an image. And one thing I love about the OpenCV functions is that they are very self-explanatory. So to do that, we'll write cv2.imRead. So cv2.im read image read. So this helps you to read in an image. You bring your parentheses, and the first thing is the file name you want to read. So let's type file name is equal to, and which file do we want to read? So over here I have some 3 different images. So any of them I want to read, I can just provide the name of that particular file. So I'll be reading the car. So we just have to type car.jpg. But if you are lazy and you can't type car.jpg, right click on car and copy the relative path, or just copy the path. So you can just copy the path, or you just type it. So I'll just put the name here, which is car.jpg. Okay, and just like this, we have read the image. Okay, so after reading the image, the next thing you have to do is to show the image. Okay, so to show the image, how do we show image? We have a function called cv2.imshow, and this will help you to show your image. But before you show the image, you have to provide some couple of parameters. First, the window name. Okay, so the window on which you want to show this image, and I will explain better when I run this code. So we'll give the window name to be, let's just call it frame, and the next parameter is the image you want to show. So you can see over here, the image should be a matrix, okay, matrix-like image. So let's just call it math is equal to, and then we are going to give it the image we want to show. Okay, so these are the two parameters you need to give the IMShow function. The window name you want to display the image, and the image itself, which is expected to be a matrix type image. All right, the next thing we need to do is to wait or allow this image to stay on the screen. So to do that, we have cv2.wait key, and this wait key helps the image to stay on the screen. So when you put wait key of 0 here, it delays forever. Okay, so it's an infinite delay. The image will stay on the screen forever. But if you put 1 here, then it's about 1 second and so on. So let's just put 0 here, and let's rerun the code. Okay, before I rerun, let me save it. So let me run this, and boom, you can see we had our image right here. So the frame I was talking about is this. So you can see the image is displayed on a frame, and the name we give it is frame. You can see this name here, frame, and it's appearing here. So you can see we are able to read in this image successfully, and this is how easy you can read in an image in OpenCV. So let's continue. Okay, so the next step we'll cover in this particular module is how to resize an image. So I'll copy this particular same comment, and I'll bring it down here, and I'll change this to be resizing image, right? So resizing images. Okay, so we'll learn how to resize an image. So you can clearly see that the image we've read in here was so big, and it's taking the whole screen. Maybe you don't want it that way. You want to resize this image to make it small. So there is an OpenCV function for that. So what we'll do is to continue with this particular code. So I'll just copy this same code, and I'll comment all of this because we are done with reading images, and I'll paste it right here. So this one, now we have to resize the image. So we've already read in the image, so we'll go ahead on this line and we'll resize the image. So to resize the image, you have to first give it the name. So we'll call this one resized underscore image, and this is equal to cv2.resize. So one thing about the OpenCV functions is that their names are so good. cv2.resize helps you to resize an image. So the first parameter you give to this particular function is the image. So this is our image we want to resize. And the next thing you need to provide is the new size in a tuple. So you bring a tuple here and you give the new size you want. So we have width and height. So what's the new size that you want? So let's say you want this image to be in shape 500 by 500 pixels. Okay, so this is the new size we want, and we can go ahead and also show this particular image. So remember, to show image we use cv2.imshow. So I'll copy this same thing, and then over here I'll call this one resized image as the frame name, and what we are going to show here is the resized image. So I'll save this and run the code again, and we should have the two images, one resized. So this is the first image, which is frame, which is the bigger image, and this is the second image, which is the resized image. So you see how easily you can resize images using OpenCV. So this is very easy to do. You just give it the image you want to resize, and you provide a tuple containing the two sizes of the image you want to resize. All right. So let me also teach you how to know the existing size of an image before resizing it. Okay, so right after reading the image, if you want to know the existing size of the image, every image have the width, the height, and the color channels. Okay, so we can type width, we can type height, and the color channel, and this will be equal to the image dot shape. Okay, so once we do width, height, color channel, it's equal to image dot shape. This will return to us the width of the image, the height of the image, and the color channel of the image. So this will help us to know the already existing size of this particular image. So for that, I can quickly just print this, and I'll put this in F string. Okay, so now I'm printing the width of the image, the height of the image, and the color channel. And these are the original ones we are reading. So let's run this and see if it works. It seems I didn't save this, so let me save it and kindly rerun it. So let's run this. And on the terminal, now you can see we have the width to be 1080, the height to be 9020, and the color to be 3 channels. So the reason why we are getting 3 channel color is that this image have some content of red, blue, and green in it. Okay, so it's an RGB image, but when you read it with OpenCV, it tends to BGR, which is another story for another module. But for now, just know that this image have 3 color channels. So that's why we are getting the width, the height, and the color channel. So this concludes on how we can resize images using OpenCV. All right, so the next thing we'll learn to conclude this module is how to convert an image to grayscale. Okay, so now we learn how to read in an image, how to resize an image, how to get the width, the height, and the number of color channels for an image. The next thing now is how to convert an image to grayscale. Okay, so let's do that. I'll copy this, bring it down here, and I'll paste it, and how to convert images to grayscale. Okay, so that's the next thing. So for that, we'll still comment this one. I think let's copy the same thing and bring it down here, uncomment all of these. So here we are reading image, getting the shape of the image, resizing the image, and after resizing it, let's try to now convert it to grayscale. Okay, so we'll call this one gray image, and with the gray image we have an OpenCV function called cv2.cvt color. Okay, so don't forget cv2.cvt color, and inside here you give it the image which you want to convert to grayscale. Okay, so you can see we have given it a resized image. You can give it any image. If you want to give it the original image, you can also specify that. Then the next thing you need to type is cv2.color bgr to gray. Okay, we are converting to blue, green, red to gray, because I told you when reading an image with OpenCV, automatically OpenCV will change the color channels from RGB to BGR. So now this image we have red here will automatically be converted to BGR. So in order to convert this image to gray, we have to use a color conversion that converts from this BGR to gray. So this is how easy you can convert this image to gray, and we can go ahead and show this particular gray image. So instead of showing the original image here, I'll just copy this and replace it so that we have the gray image to show. So I'll paste this one right here, run this particular one. So here we go, and you can see this is our grayscale image. Okay, so it's also on frame. If in case you want to name it for proper name convention, you can just copy the same name and paste it in the gray image here. So the frame name will be gray image instead of frame, so that you don't mess things up. So now we'll call this one gray image as well, and I will rerun this, and now we have it on the name of the frame. Okay, seems I didn't save this before rerunning. So let me save this, and I'll close this and rerun once again. Okay, so here we go. Now we have the gray image right here. So this is the original image we've resized, and this is the resized image we've converted to gray. And I know most of you will be asking, is it only gray that we can convert image to? No, the answer is no. We can convert to a lot of other color channels. So you see we have BGR to gray. You can have BGR to, so you can see all the other color channels. So we have a lot of color channels you can convert these particular images to. So you can convert it to BGR to BGR 565, BGR to BGR BGRA. So HSV. So we have a whole lot of conversions you can do. And this is how resourceful OPCV library is. It has a whole lot of things you can do. So just remember that you have to type cv2.color, then you type the first color in which the image is, which is BGR, then you convert it to gray. Okay, so that's if you want the image in gray, which is what we want. Okay, so this is how easy you can convert an image from BGR to gray. All right, guys, so before we conclude this particular module, one thing you should always put at the end here is to put cv2.destroy all windows. And this helps you to just destroy all the windows. Once you close the program you are running, everything goes off. There will be nothing running at the background, so always be mindful to put it here. And this is all for this particular module, so I can't wait to see you guys in the next module, which is module 2. All right, guys, so welcome to module 2 of our OPCV for beginner course. In this module, we'll focus on how to draw shapes on images. In the previous module, we learned how to read in an image, convert image to grayscale, resizing image, and also we've learned how to get the width, height, and the color channels of an image. So we'll continue by learning how to draw these shapes on images, and OPCV have a function that helps you to draw various shapes on images. And I can't wait to teach you that. So before we get started, let's quickly comment this code we've learned in module 1. And what I'll do is to copy this right here and I'll bring it down, and let me quickly put up a comment here to notify that this is module 2. All right, so down here, let me quickly paste this, and instead of loading and displaying image, we have to change this to drawing shapes on images. Okay, so I'll uncomment this code quickly because this will help us to read in an image, and on that image, we are going to draw some shapes. All right, so don't also forget to put cv2.destroy all windows here, so that when you break this program, every background activity will stop. Okay, so make sure you always put it there. All right, so let's learn to draw our first shape, which is my favorite shape in this case. We will learn how to draw a circle. So to draw a circle, OPCV have a function which is very easy, and all you need to write is cv2.circle. Okay, and with cv2.circle, you have to give it the image you want to draw this circle on. So we've read in this image called car.jpg, which is right here, is a Tesla car. At least who doesn't like Tesla? So I'll change that image for now. Let's use another image. So for that, let's use soccer.jpg. So I'll quickly replace car here with soccer, and to be sure everything is working, let's first run this code to make sure we are able to load soccer correctly. All right, so these are 3 good guys here, 2 in Arsenal jerseys and 1 in is that a Brazilian jersey? Yeah, if I'm right, playing beach soccer. Okay, so the image I've loaded successfully, so let's go ahead and put a circle. So in this particular parenthesis, you have to give it the image you want to place the circle on, and in this case we've read our image here, so we'll give it this image. The next thing to give is the center point. Okay, where do you want to put this particular circle on the image with regard to x and y? Okay, and it takes that as a tuple. So let's try to put it somewhere at the center of the image, even though we don't know the shape of the image, which I teach you how to check it out. But what we'll do here is to just give it some numbers. So let's put it at, maybe, why not do 80. So 80 on the x-axis and 80 on the y-axis. From there, you also need to specify the radius of the circle. So how big do you want this circle to be? So for that, let me give it a radius of 60. Okay, from there you need to specify the color for this particular circle. So it takes 3 numbers for the colors. Okay, so I told you when you read an image into OPCV, the color channels change from your number RGB to GBR. So in the color, you have to provide 3 different numbers. So let's say we provide 0, 0, 0. Providing 0, 0, will get a black image. Okay, The first 0 stands for the blue color channel. So we said we want to convert the blue color channel to 0, the green color channel to 0, and the red color channel to 0. So BGR all to 0. And the numbers start from 0 to 255. So assuming we replace our first number with 255, that means we want this to be blue. Okay, so we say 255 and all the other color channels to 00. We can also go all white by writing 255 and 255 here. So we want to make this image white because we've sent all the color pixels to the maximum 255. We can mix two colors together. Let's say, for instance, we can place 0 here and we can mix blue and green together. Okay, so this is for blue and green, and the threshold is between 0 to 255. So you have that freedom to play with these numbers to get the desired color. For now, let me just change here to 0 so that we get a blue color. From the color, the next thing you have to specify is the thickness of your circle line. So for the thickness, I can place 5 here to make it a little bit thick, and this is all you need to draw a circle. So for that, I'll quickly run main.py, and you can see we have our circle right here. So the circle is at position 80, 80. Okay, so 80 on the x-axis, that means from here to here is 80, and 80 on the y-axis. So the distance from here to here is the same distance from here to here. Okay, so that's exactly what we are doing. If you want to shift this furthermore, you can quickly change the position right here. So we can change the x-axis. Maybe we want it to go in the middle. Let's make this 300, and this will shift the image to the middle. Okay, so you can see we have it somewhere here, and y remains what, 80. So you can play with this. And one thing you can also do, which is a simple hack, let's say you want this circle to be filled. Okay, you don't want any space in the circle, you can quickly replace the thickness here with -1, and this will quickly fill the entire circle with a blue color for you. So you can see how nice we had a blue color filling the whole place. Okay, so this is how easy you can draw circles using the OPCV library. So from circles, we'll now move on to rectangles. Okay, so we'll move on to how to draw a rectangle using OPCV. And for that, I have an image here we can all reference to. So I'll be sharing all these resources with you guys. Okay, so we'll use this to draw a rectangle. Another image is here. So with rectangles, it's also pretty much easy to do. So let me start drawing rectangles, and then I can reference the image. So the function is also self-explanatory, cv2.rectangle, right? And inside here, the first thing you do is to provide the image on which you want to draw the rectangle on. And the second thing is the point 1. To draw a rectangle, you need 4 different points: x1, x2, y1, y2. So the first point you need to specify is your what? X1 and your y1. So x1, y1, and let's use this as reference. So you can see you take your starting point and your width and your height. So let's say for our S1, our rectangle will start from 60, and our Y1 will take 60 as well. Then we'll continue by giving the second point. Okay, so with the second point, which is point 2, we'll give it 50, 50. Okay, so 50, 50. And from there, you have to specify the color again. So let's make this one blue as well, or we can mix blue with green together. So let's make it 255 here as well to mix that color up. All right. And the next parameter is the thickness of this particular rectangle. So the line thickness, and we can keep this at 4. And just like this, you've just drawn a rectangle using OPCV. So I'll quickly run this, and we can see where is our rectangle. You can see it right here, very small. So let me change the color to red. I like red, so let me make here 255 and convert all of these to 0, and also this one to 0 as well. And also I'll make it a little big, so let's make it y2 to be something like 100. Okay, so something like this, and let's see how it looks. And boom, you can see this is our rectangle right here. So you can see the red color here, and it's looking very great. So this is how you can draw rectangles using OPCV. You just need your 4 points, or get your 4 points right, and then you draw the rectangle nicely. So let's move on to the next shape. And the next shape here is a line. So let's draw a line. To draw a line, pretty simple, cv2.line, and the first thing you give is your image. Okay, so the first thing you give is your image, and just as rectangle with lines, you need to specify 2 points. Okay, you need to specify 2 points for a line. So with this image, you can see you have your image, your starting point, your width, and your height. Okay, so with line, you need to specify 2 points. And to further explain this, let me open up Paint and teach you how the line works. So to draw a line, let's pick up this line tool, and let's say we just draw a line like this. So with line, the starting point needs 2 points. So let me use text here. So the starting point here needs your x1 and your y1. Okay, and your end point here also needs 2 points, which is your x2 and your y2. Okay, so this is all you need to know to draw a line. Where do you want to start in regards to x and y, and where do you want to end the line in regards to x and y? Okay, so that's what we have: x1, y1, x2, y2. So let's quickly draw a line. Our starting point, let's start from 0, 0, so that we can just draw it right from the start. Then our ending points, so let's really make this one long, a little bit long. So we'll stop at, let's say, 90 on the x and 90 on the y, because I just want it to be somehow diagonal. The next thing is your color again. So with color, I will go with blue. And the final thing you need to give this line is the thickness. Let's go with 4. Okay, so this is how simple you can draw a line. Let's save this and give it a run. And boom, you can see we have our line here. So we start all the way from 0, 0, and on x-axis we've gone 90 from here, and then from y-axis we also gone 90 from the top. So this is 0, 0, 90, 90. Moving on, our next thing is how to place a text on an image. Okay, so you have an image where you want to put some text on it. Let's learn how you can place a text on an image. It's also very simple. So first you do cv2 dot put text. So the name of the function is put text. Okay, the first thing you have to do is to give it your image you want to place this text on, then the text you want to put. So what text you want to put? We just want to put OpenCV for now. Okay, the next parameter is the origin point. What is the point? Which point do you want to place this text? Okay, so I want to place this text, let's say somewhere on our circle, or somewhere far from our circle. So on the x-axis, let me just do 400 or 350s, so that it will be somewhere closer to the circle, and 90. Okay, so this is the place or the position on the image at which I want to place this text. Okay, so that's it. The next thing is the font face. Okay, which font face do you want to use? OpenCV has a lot of font space. Just open your Chrome and just search for OpenCV fonts. So let me open this first link. And OpenCV has a lot of fonts. Okay, so you can see here we have font hashes simplest, font hashes plain, font hashes duplex, and these are different fonts. So you can use any of these fonts. So let's just copy this first font and see if we can use it. So let's type cv2. That will be cv2.font hashtag complex. Okay, so there are other fonts. Immediately you start typing, you can see we have a whole lot of fonts you can use. Okay, so let me use font hashtag complex, and then this will follow by the font scale. Okay, so for the font scale, let me just put 4 here, and that's how big I want this to be. You have to also specify your color. So with the color, we'll go with let's just go with white. Will white be nice? Or let's go with green. So I'll give this 0, 255 and 0 as well. Then the final thing here will be the thickness. Okay, thickness. So I'll just give it thickness of 3 here as well. And just by writing this, you've successfully placed a text on your image. Let's run this to confirm. All right, so you can see this is our text and it's even out of the frame. OpenCV is out of our frame, so we can decrease our font scale a little bit to make it smaller. So let's make it 1 and see how it will look. All right, so you can see how nicely OpenCV is written on our image, and this is how easy you can place text on your image. All right, the next thing we'll do is to draw an ellipse. Okay, let's learn how to draw an ellipse. So the thing with ellipse is that it takes in a lot of parameters because it's such a complicated shape. Okay, so cv2 dot ellipse, and inside here you have to give it the image as usual. The next thing you have to give is the center point. Okay, so you are familiar with the center point by now, where on the image you want to place this particular ellipse. So let me just put it 255, 255. That's not bad. All right, right from specifying your center points, you have to also specify the axis. And I would like to explain this axis once we run the code and we tweak this a little bit so that you get familiar with it. If I just say anything here, you just get confused. So the first axis, let's just do the axis should be 100, 100. Okay, so let's just do 100, 100 from the start. And the next thing you have to also specify is the angle for the ellipse. Okay, so let's just put it at 90. Then the next parameter here will be your start angle. Okay, where do you want to start the angle from? So let me start from 0, and my end angle for this particular ellipse, we can make it round. Then we can just put, let's say, 360 here. We can later reduce this to make it very small. The next thing is your color. So with this, I will just make this color blue as well. So 0 from the color. Then the last one you need to specify is your thickness. So let's make this 5, and let's try this out to see how this ellipse will look on our image. And here we go. So you can see this looks like a perfect circle. Okay, this looks like a perfect circle. All right, what if I want this to look like an egg? Okay, I want it to look like an egg so that it will stretch a little bit, whereby the y-axis will be longer. Then I can use this to tweak it. Okay, I can use this, which is the axis, to tweak it. Let's say, for instance, I put 50 here and 100 here. So let's look at how this will look now. You can see how it starts to look. So it has shifted to the x-axis 50 and the y-axis is 100, 100. So we can further stretch this anyhow we want. Okay, and this is how easy you can draw ellipse. In case you don't want it to be closed, then you can tweak the angle. So the start angle is from 0. You can maybe draw up to 300, which will not close the entire thing up. So I'll hit enter on this, and you can see from 0 to 300. Okay, from 0 to 300. So it's not a complete ellipse in this case. Okay, so you can just tweak this. You can tweak the axis to make it look how you want, and you can always also tweak the start and the end angle as well. The original angle, you can also tweak it, so you can change it. Maybe you want the original angle to be 0. You can also tweak that as well. Let me give this a final run, and let's see how this looks. So you can see when I start the original angle from 0, this is how it will look like. And this is how easy you can draw an ellipse. So the final thing for this module is to teach you how to draw an arrow line. Okay, so let me teach you how to draw an arrow line, and that is just as our line will be drawing. So I'll just quickly draw this. So cv2.arrow line, and inside this you provide your image. You provide your position, the start point of that particular line. We've drawn line here, so it's the same kind of thing. Where do you want this line to start? Where do you want this line to end? You give it the color and the thickness, and that's all you need to draw an arrow line. The only thing that changes is the function name arrow line. Okay, so that's pretty much it. Let's give this a try, and you can see we have our arrow line right here. So this is how easy you can draw shapes on an image using OpenCV. And this concludes our module 2 for this particular course. If you have any comments, just make sure you place them in the comment section for me. All your questions, put them in the comment section, and I can't wait to see you guys in our next module 3. Alright guys, so welcome to module 3 of our OPCV for beginners course. Before we continue, let's do a quick recap. In the previous module, we learned about how to draw various shapes on images. We learned how to draw circles, rectangles, line, text, ellipse, arrow line on images. Okay, so in this module, we'll be learning how to handle video files using the OPCV library. We'll learn how to read in a video file, play that video file, save that video file, get our feed from the webcam, and a whole lot of things. So let's get started. First of all, I'll comment this code, and I'll be sharing all these resources with you guys. So no need to worry, including all the files you can see here. I'll be sharing all of them. And what I'll do is to copy this so that I can also comment it right here. So let's put a comment that this is the module 3. And down here, I'll quickly paste this. And over here, let's just write working with video files in OPCV. Alright, so the first thing I'll do is to teach you how to read in video files. So you have a video file, I'll teach you how to read it using the OPCV library, which is very easy, okay? So over here, you can see we have two different video files. So we have dance1.mp4. When I play it, you can see we have some girls dancing. And we are coming to read this video file using OPCV and see what we can do with this particular video file. Alright, so in OpenCV, to read a video file, first you need to create a capture object. So we call this cap, and it's equal to OpenCV have a function called cv2.video capture. Okay, so you write video capture, and inside this parenthesis you give the path to your video file you want to read. Very easy. So over here our video is here, and the name of the video is dance1.mp4. so I'll quickly just type dance1.mp4, and this is it. So we have now created a capture object which we've given the path to our video file. Alright, because this is not an image and it's a video file, what you have to do is to take it in a loop, take it frame by frame. Okay, so image is a single image, so we don't need to loop anything, but with a video, which is just like plenty of images stacked together, we need to take it frame by frame. So that's why we need to create an infinite while loop. Okay, so I'll just call this while true. That means we want this loop to run over and over and over. Okay, and I'll take ret. I'll also take frame, which is our video, is equal to cap.read, and this will help us to read our video file from our capture object in our while loop. Alright, so now we are reading this video file, so let's quickly show it. Okay, so to show the video file, we use the same old function we are used to. So cv2.imshow, okay, and then we give it our window name, which is frame, and now the name of the matrix we want to show, which is our frame as well. So the name of the video we want to show is also our frame. And after reading the video file and showing it just like the image, we need to make it stay on the screen. Okay, so for that, what we'll do, say cv2.wait key, and instead of 0 here, we want to put 1. And the reason for this one is that this is a video file, so we want to take each frame of this video file each 1 millisecond. So every 1 millisecond will get 1 frame of the video file. Okay, so that's why we need to put this 1 here, and just by doing this, we've read in our video file and we are able to show it. All right, so for a good practice, I told you to put cv2.destroy all windows here. Okay, so that after breaking your code or breaking your program, this will destroy every windows. Okay, and also one thing you have to also do in addition or in regards to video file is that you have to put cap.release here. Okay, so that we release this capture object immediately we close the program. So let's try this out and see if it will read and display our video file successfully. So over here in the terminal, I'll just type main.py and hit enter on this. Oh, okay, I got some errors and I know why. So let me clear this up. This should be a Python or pymain.py. Hit enter on this again and this should run our script, and voila, you can see we have our video file here. So this is how easy you can read in video. The video is very short, so you can see how it ended and we got this kind of, we are out of frame, so that's why we are getting this error. So one thing we can also do in this case is to resize this video, because I taught you how to resize the video file. Okay, so it's very easy. So we can call it frame is equal to CV2.resize. We give it our frame and then you give it a shape you want, how small you want it. So we want 640 by 480, and we can run this again and we will all confirm that now our video file is a little bit smaller. Okay, so that's how you can resize, and resize applies to both video files and images. Okay, so you can resize all of those things using the OpenCV library, and just as what we've learned, we are just building upon everything, and you can see how smooth everything is. Okay, so that's nice. Now the next thing I'll teach you here is how to get your feed from the webcam. Okay, so instead of video file here, you want to run this script on your webcam so that you can see yourself, or you can take video of yourself to do something with it. So for that, instead of giving the path to any video file you have, all you need to do is to specify your camera index in this particular parenthesis. So this parenthesis, you can specify 0, okay, and 0 will automatically pick up your computer or your laptop original webcam. Okay, so when you specify 0, that's what it will pick. And as of now, the lid of my computer is closed, so when I run this one, it should work, but I should get a blank screen. Okay, so let's see if so you can see, so it's working, but I'm getting a blank screen because I've closed the lid of my laptop. If I wanted to raise it small, you can see some light, but I'm going to test this using the webcam I've connected to this computer. So let's close this. So to close this, you can see you are forced to close this. So we also solve that problem so that we can press a key on our keyboard to close this particular program, because when I close here, it will never close. You can see it will never close. So what we'll do is to add a code that can be able to do that, so that we can hit any key on our keyboard to make this close smoothly. Okay, so for now, I'll just press Ctrl C in the terminal to interrupt this particular program. Let me clear the terminal, and what I'll do now is to specify 1 here. Okay, so because I have also a webcam also connected to this particular computer, I can specify 1 to get the webcam working. So 0 picks the original webcam, okay, of your laptop. So I'll put 1 here in order to connect to my webcam, because I already have one webcam connected to this. All right, I'll save this, and also in order to close this smoothly, instead of cv2.wait key 1, what I'll do is I'll put a condition here. If cv2.wait key is 1, and so I'm doing a bitwise AND operation here, 0xff is equal to ord into parenthesis q. So I'm just saying that if the q key is pressed on the keyboard, which is equivalent to 113, all I want to do is to break from this particular loop. So now you don't need to force close this program. If you press the Q key on your keyboard, this will particularly shut the program automatically. Your capture device will be released and all windows will be destroyed. And you can also change this Q to any key you want. Okay, so it's not mandatory that there should be Q here. You can change it to any key you want. All right, so let's now test this out and see how it works. So let me run this, and you guys are going to see me in a sec. And here we go, guys. You can see me live from the webcam. You can see how you are getting the live feed from the webcam. So this is working great. This is how you can just use OpenCV to get your live feed. So now we are going to test this functionality. When I press Q on my keyboard, you can see automatically the program closes gracefully. Okay, there is no error on your terminal. So this is how you can do it. You can put any um alphabet here that you want to use. Okay, so this is how to work with video files. The next thing I'm going to teach you is how to write a video file. Okay, so the video feed we are getting, we want to write this video feed to a file here, just like these video files we have here. Want to write that video feed so that we'll be able to use it. Okay, so you want to save the video feed you are getting from your webcam. It's also very easy to do using OpenCV. All right, so for that, we need to first create our codec, okay, the video codec. That's to say the format of the video. Do we want it to be in MP4 format? So we have a whole lot of formats, which I'll show you. So you can see from this image here, we have a whole lot of formats, okay? So we have MP4, XVID, DIVX, so a whole lot of them. When I share this resource with you, you can go through and use any codec as per your need. All right, so for that, what I'll do here is I'll call this codec, and codec is equal to cv2 dot video writer dot 4cc, okay? cv2.videowriter then 4cc. So in here we have to provide the codec. So you can see C1, C2 all the way to C4. So what we'll do here is to put asterisk, and inside you have to put in the codec you want to use. So for now, let's just write MP4. Okay, so we want to use the MP4 format. So make sure you put MP4V because that's what you need to specify, MP4V inside this particular parenthesis. Okay, now that we've created the codec, we can also specify the output size of the video we want. Okay, so let's call this size, and this will take the width and the height. Okay, so inside here we'll just take this same size, 640 by 480. So this is the size of the video we want to save. And the next thing here we need to do is to create our video writer object. Okay, so I'll call this writer, and writer is equal to cv2.videowriter. Then you give the name of the video you want to save. So we are calling this output.mp4. So just make sure you give it a name which you can remember. And the next thing is the codec. Okay, so we specify the codec here already, and followed by the frame per second, or FPS, which we specify to be 30, and the size of the video. Okay, so this is very easy, guys. This is very easy. Then from here, to write a video file, all you need to do is to come and do writer.write, and then you give it your frame because you want to write this frame. So writer.write, then frame. Okay, so that's all we need to do to get it working. We can also prevent this resizing here because we don't need it. So after doing this, when you run this code, it will just write that video file and save it in your working directory. All right, so there are some couple of things you can do to enhance your script. So let me also show you this. So you can do here, if not ret, and I'll teach you what ret is in a sec. What you want to do is to break the program. That's to say, if there is no video available, or if your video capture is not working, all you want to do is to break the program. You don't want to run all this code. So in case over here you have to specify a video file and you make a mistake, this guy will catch it here and break the program. And ret here just returns you a boolean, okay, true or false. So if there is a video file and the video is good to read by OpenCV, ret will be 1. If the video is not good to be read by OpenCV, ret will be 0. Okay, so yeah, it's just a boolean. So we are just saying if the video file is not good, the video file has a problem, we'll break right here. Okay, so that's how we can do that. So let's run this code to see if we can write a video of myself, and then we can also able to play it. So let me run this. And here we go, guys. So as I'm speaking now, this video file is being written in an output file. So we've given the name output.mp4, and you can see that file has been created right here. So now I think I've recorded myself enough. So let me just quickly click on Q to gracefully close this program, and we have the output file here. So let's see if it will open. It's not opening in VS Code, but I can open the same thing here on my desktop, and there is a folder called OpenCV course, and over here you can see it right here. So this is the video we've just recorded. I was doing something, and then all of a sudden the camera pops up and I started talking. So you can see how this works so nicely. You can just record a video of yourself doing something, maybe object detection and other things you are doing. So this looks great, and I'll close this. It has ended, so let me quickly close this. So that's how you can record a video of yourself. And also remember guys, when we're working with images, I showed you how to get the width and the height of the images, okay? So for video files, we can also do the same thing. So to get the width, we can say our width is equal to, we can use the cap.get, and then inside here, just put 3. So 3 here will get your width for you, so the width of the video for you, and height you use 4. So with height, you do cap.get 4 to get the video height for you. So you can go ahead and print this, maybe if you want to see it on the terminal. So you can print width, height to show it on the terminal if you want. And for now, I'm not going to show myself. Let me just give path to one of the video files I have here, which is called dance1.mp4. Okay, so let's run this and see. And here we go. So yeah, it's running. It will end soon. Okay, we had no error, but you can see we had the width and the height of the video. We've stopped resizing. We've commented that out. So the original width is 1920 and the height is 1080, and it's a float value, so you should be mindful of that in case you want to use this value somewhere which requires integer. Then you have to make sure you cast it to integer before using it. Okay, so yeah, that's it. Also, you can see one thing, that the video file we've just read is very, very, very short. So it plays and then it stops. So in case you want to play this video repeatedly, there is a hack you can do. You can check that, okay, if not read, so if there is no video file, what we want to do is to reread this video file again. So that's a hack around it. So if the video file is done playing, what you can do is to reread it in your particular loop once again, and instead of break here, you don't want to break, just want to continue. Okay, so this will play this video file repeatedly. And for now, let me resize it to make it small so that we can see this video file in action, but now it will play continuously. Okay, it will play continuously. When it's done, it will start again. So you can see you can play this over and over and over and over. Yeah, so that's it. You can see that's how it works. So guys, this is all for module 3. So in this module, we learn how to work with the video files, how to write video files, and also how to get our feed from the webcam to work with it. And I hope you've learned a lot in this module. If you have any comments, just make sure you put it in the comment section for me. Okay, and all the resources and everything will be made available. Thanks for watching, and I'll see you in the next module. Guys, welcome to module 4 of our OpenCV for beginners course. In our previous module, we learned how to work with video files. We've learned how to write video files, and we also learned how to get our real-time feed from our camera. In this module, we'll be focusing on how to rotate image and also how to crop image. So without wasting much time, I'll just quickly go ahead and comment what we have done in the previous module. And as usual, I'll copy this one down. And instead of module 3, this is module 4. And over here, I'll change this to image transformation. So the first thing, as usual, is to read in an image. And for this one, I'll quickly do that. And because you want to transform these images, I'll go ahead and get the width and the height of the image. So for this, I'll call this the width, and this the height is equal to our image dot shape. And because image dot shape retains the color channel as well, we just do comma, and we just call this channel. We will not be using it though, so let's just call this channel, and this will give us the width, height, and the color channel of our image. So let's just go ahead and show this image. All right, so just like this, we'll be able to visualize this image. So let me quickly run this to make sure that whatever we have done is working. And here we go. So this is the image we'll be working with. So now let's go ahead and see how we can crop this image. Okay, so to crop an image is very simple. You just need to get the coordinates you want to crop. Just like you are drawing a rectangle, you have 4 different points, and then you draw the rectangle. So in this case, we want the 4 different points so that we can crop that image. So I'll call this one cropped image, and crop image will be equal to our image. And inside here, you need to specify the portion you want to crop. So let's say, for instance, let me just give some numbers here so that I'll show you how it works. So I'll be cropping from 50 on the X1, and the Y1, let's say I want to crop 300. Then we'll move on to X2 and Y2. So for X2, let me take 50 300 as well. We can change this later. And what I'll go ahead and do is to show this one as well. So I'll call this one cropped image. Okay, so the frame will be cropped image. And over here, we need to replace this with cropped image. And let me quickly run this and let's check. So this is the portion of the image we've cropped. Okay, so first you just need to get your coordinates you want to crop out of this image, and then you extract that particular portion of the image exactly. You can increase these numbers as you want. So how it works is we have x1, y1, x2, and y2. So once you know the points from the original image you want to crop, it becomes very easy for you to crop the image. Okay, next step, let's just learn how to rotate the image. So to rotate the image, you need to get a center point of the image. Okay, so the center point of our image will be half of our width and half of our height. So I'll call this center, and center will be equal to our width divided by 2. So we'll use this sign in order to get it as integer, and our height divided by 2. So this will get the center point of our image for us, and this will help us to be able to rotate our image based on this center point. The next step is to get your rotation matrix. Okay, so we'll call this one rotation, or let's just call it rotate matrix, and this will be equal to cv2 dot get rotation matrix 2d. And inside this parentheses, you have to give it your center point. So we already have the center. So let's give it a center. The next thing you have to give it is the angle of rotation. Okay, how many degrees do you want to rotate it? So let's declare this here. Let's just call it an angle. An angle will be equal to, let's say I want to rotate it for 45 degrees. So I have to put 45 here. Then I will just type in angle right here. And our final parameter here will be the scale. Okay, so for the start, I can just put 1 here. Okay, so that we have the scale to be 1. So now that we have this in place, we can actually get our rotated image. So let's call this rotated image, and this is equal to cv2 dot warp affine. Okay, and inside this particular parenthesis, you have to give it your image you want to rotate and your rotation matrix. So the next thing will be our rotate matrix. Then from here, you need to give it the width and the height of your image as a tuple. So you put this here and give it the width and your height. And just by doing this, you get your image rotated. So go ahead and show the rotated image as well. So let me paste this here. And instead of our normal image, now I want to show the rotated image. Okay, so let me quickly run this so that we can see the result. All right, so this is our cropped image, this is our original image, and this is our rotated image 45 degrees. So you can see that it is very easy to do. I think there is a little bit of steps to do, or just about 3 lines of code if you want to do the rotation, but overall it's very easy to do. You just have to get the center point of the image. Then the next step is to get your rotation matrix. After that, you combine both the rotation matrix and the image together with the width and the height of the image as a tuple for the warp affine function. And just like that, you get your image rotated. So this is how you can crop an image and also rotate image using the OpenCV library. And this is all for this particular module. Thanks for watching, and as always, if you have any questions, just leave it in the comment section and I'll make sure I address them. Alrighty guys, and welcome to module 5 of our OpenCV for beginners course. In this module, we'll be looking at how to blur an image and also detect edges in an image. So without wasting much time, I'll quickly comment our previous code, which we learned about how to rotate image and also do some cropping on images. So let me quickly comment that. And over here, I'll specify that now we are on module 5. And down here, I'll just paste this, how to blur and detect images. And as usual, the first thing we have to do is to read in an image. And since we have that code in our first module, I'll just come all the way here and bring in this code which reads an image. Okay, so I'll quickly paste this code here and I'll try to uncomment it. And in this case, instead of car.jpg, let's use soccer.jpg. Also, don't forget to always put cv2.destroy or Windows right here, okay? Never forget to add that. And let me quickly test this before we continue. So I'll run the code by just typing main.py. And voila, here we go. So our image pop up very nicely. So now we'll go ahead and learn how to blur an image. Okay, so to blur an image is very simple. OpenCV have a function for that. And all you need to type is, let's say this is our blurred image. And our blurred image is equal to cv2 dot. We have a function called Gaussian blur. And inside this Gaussian blur, you need to give it your image. And the second thing you need to give is your kernel size. But this kernel size is usually given as odd numbers, okay? So you have to provide odd numbers. Let's say by 3 by 3 pixels, 5 by 5 pixels, 7 by 7 pixels, 11 by 11 pixels, and so on. The reason why we don't usually give even numbers is that with even numbers is very difficult to find a center pixels when you are trying to do computations using these images, okay? So usually it's advisable you give odd numbers, okay? With odd numbers you can find a center pixel for your transformation. So yeah, that's just it. You can read more about that as well, but usually it's odd numbers. Okay, so Gaussian blur, we give it this, and then you can specify your sigma s, which is a floating value you can give. So let me just put out 2 here, okay? And with this, you are just done. You are able to blur an image. And as always, I'll just go ahead and show this blurred image and see how it will look like. So I'll change this frame name to blurred image, which I'll put here, and I'll also change the image to our blurred image. Alrighty, so that's done. I'll save this and hit rerun. And here we go. So you can see this is our original image and this is our blurred image. Okay, so I'm just applying 3 by 3 candle size, and you can see the blurry effect is not that much. So if you need more blur, then what you can do is to increase this candle size. So to see a drastic effect, let's just do 1111 so that you can just quickly see it. So hit run again, and you can see this image was actually blurred. So yeah, that's how you can do blur using the OpenCV library. There is another way to also apply blur. So we have, I'll call this one blur, and this is simple cv2 dot blur. And inside here, you just give it the image you want to blur. Also, you give it the candle size as well. So I will still give it maybe 5 by 5 candle. And you can specify this, which is none. So there is no need even specify anything again. So just give it a candle size and you are good to go. So we'll go ahead and show this one too as well. All right, quickly save this and let me rerun this for us to see. And this is the normal blur, the one we just did, and you can see it's looking good. So these are 2 ways of applying blur using the OpenCV library. Okay, so that's it. Now let's move on to how we can detect edges in images. Okay, so to detect edge, let's call this edge image, and this is equal to, we have a cv2 function called cv2.canny. Okay, so canny edge detector, and canny edge detector will help you to detect edges in images. Okay, so for that, you also give it an image you want to detect edges on. And the next thing you need to provide here is the threshold. Okay, So the first threshold, let's start with something like 100, and let's give it out maybe 200 here. So this will be our threshold, and let's just show this image and see the edge effect, and I'll teach you how to increase this threshold in order to get a better result. Let's call this one edge image and edge image here as well. I'll just save this and quickly I'll run this once again. So we are looking for our edge image, and you can see how it looks like. So it tries best to get rid of the noise in order to only get the subjects in the image. But we still got some couple of noise though, and you can filter this noise by just changing the threshold. So let's try to modify the threshold and see what we'll get. All right. So instead of 100, 200, let's do 200, 200 and see how it will look like. And you can see we are losing some details here. So the secret for getting a better edge image is by playing with the threshold. Okay, so you have to play with the threshold, you have to play with the numbers there in order to get a very good edges being detected. Okay, so yeah, that's how you can do edge detection, and this is how simple it works. Okay, so guys, that's all for this particular module. Thanks for watching. If you have any questions, as usual, just make sure you leave them in the comment section for me. Hi guys, and welcome to module 6 of our OpenCV for beginners course, and this module happens to be the last module in our OpenCV for beginners course. In this module, we'll be looking at how to do object detection. Okay, how to detect objects in images or video files. In our previous module, we look at how to blur an image, and we look at two different ways of blurring an image. We also look at how to detect edges in an image. So I'll just go ahead and comment this code out, and then we can get started with our module 6, which happens to be our final module. So module 6, and module 6 is just for object detection. Alrighty, so the first question that comes into mind is, what is object detection? And I'm going to teach you that by using this image as an example. So simply, object detection involves localizing an object in an image. So given an image which consists of many objects, then object detection model have to just draw a bounding box. So as you can clearly see in this particular image, there is a bounding box drawn across every object, and there is the name or the class that particular object belongs to. And that's simply what object detection is about: to localize an object in an image and give out the bounding box information and also the particular class that particular object belongs to. So that's what we are going to do. And to do that, we'll be using Australities. Okay, so Australities is a computer vision or machine learning. They are into machine learning, and they train computer vision and also integrate computer vision models into their workflow. So we'll be using Australities, and I'll teach you how to use most of the YOLO models to detect objects in very few lines of code. So first of all we need to do is to pip install Australities. Okay, I have already installed this, so it will not take any time. I'll get requirements already certified. But in your case, make sure you are an active internet connection because it's going to take some time to install. So mine is installed successfully. And the next thing to do is to import YOLO from Australities. Okay, so I'll say from Australities, I'm just going to import YOLO. And it's that simple. So after the import, the next thing you need to do is to load the model. Okay, so for the model, we say our model is equal to an instance of our YOLO we've imported, and inside here we specify the type of YOLO model we want to use. So here we say we are going to use YOLO V8S, okay, which is the smaller version of YOLO V8. We can also use YOLO V8N, okay, smaller n, which is the nano version of the YOLO V8 model. And the nano version is the smallest among all, then followed by the YOLO V8S, which follows the nano version. Then we also have YOLO V8M, which is the medium version, is very big, so it requires a lot of computational resources to run. We also have the most accurate one, but very big, which is YOLO V8L. Okay, so this is the large version. And because Australities have also integrated YOLO V9, you can do the same thing by using YOLO V9, which is an upgrade of YOLO V8. So you can do YOLO V9, N, S, and so on. But we'll be using YOLO V8, or we can even test YOLO V11. So we have YOLO V11 as well, and there is YOLO V10 as well. So anyone you feel like using, you can also use YOLO V12, which is currently the newest version as of now I'm recording this video. But let's just use YOLO V11, and we'll use the nano version. Okay, so you can test from YOLO V11N, YOLO V11S, YOLO V11M, YOLO V11L, which is the largest version. But because my computer is not having a graphics card, I'll go with the nano version, which my CPU can handle well. So I'll just do model is equal to YOLO, and inside here I give the name of the model I want to use, the pre-trained model I want to use, because this is going to download the model. Okay, so when I run this code as it is now, it will go ahead and download this particular pre-trained model into my working directory. So let me just test that out. Let's write python main.py as usual, and I'll hit enter. And make sure you have internet connection, because it will require internet connection to download the model for you. Okay, so I got some error, no such file directly YOLO V11. Oh, okay. So for YOLO V11, the name is kind of confusing. The names are YOLO V, but with the YOLO 11, there is no V, it's only YOLO 11N. So let's clear the terminal and try it out. There is no V attached to it. So you can do YOLO V up to YOLO V10, but when it goes to 11, it's YOLO 11. Okay, so there shouldn't be any V, so it should be YOLO 11N. And if I'm right, this should go ahead and download the model, and you can see it just kick off the downloading process, and just like that we have downloaded the model. It's a very smaller one, and you can see it right here sitting in our working directory. So the model downloaded successfully, and now we are about to use this model to perform some object detection. So for that, I'll call it results, and result is equal to our model. And inside here, if you want to perform detection on image, then you have to give the path to your image. So I have some couple of images here. I have soccer.jpg, I have car.jpg, I have ball.jpg. So we can use any of the images here. So let's try our ball.jpg. Okay, and this is going to detect every object on this particular image. And one thing you need to specify, you shouldn't forget, is save is equal to true, so that this will go ahead and save the result for you. So just like that, and I will be able to run this particular one. All right, so the program have finished running, and you can see there's a result saved to runs, detect, and predict. So when you come here, we got a new folder called runs, and when we open runs, we have detect and we have predict, and inside predict we have ball.jpg. But this time around, you can see every object in this particular image has been detected, and it's looking great. So this is how simple you can detect objects on images. Okay, if you want the bounding box informations and the class names as well, I can quickly paste this code here, which will help you to get that. Okay, so this code helps you to get the bounding box information. So there are different ways of getting these bounding box informations too as well. You can see we can get x, y, width, and height. And to get that one, use result.boxes.xy width and height. So this gives you the center x, center y, width and height. And you can also get the normalized version, which is sy, width and height n. So it's the same thing as this, but this one has been normalized. You can also get xy. Okay, that one gives you the top left s, the top left y, the bottom right x, and the bottom right y of the bounding box. Okay, but the next one here is the same as this, but the normalized version. Then we also need the names. Okay, so if it has detected a person, it should write the names for us. Okay, what has it detected in the image? Is it a person? Is it a ball? Whatever it has detected, we can get it. And also we have the confidence. So the confidence tells you, okay, if it has detected a ball, how sure is it that that is a ball? That's why when you open this image here, you can see we have person and we have 0.90. So this shows that it has detected person, and the model is 90% sure it has detected a person. The ball here, 86% sure that the model has detected a ball. So we can access all those informations to in the code. So over here, let me just go ahead and print. I'll print first, I'll print the name. I'll also print the confidence, which is const, and finally I'll print the XY, the first one, X, that's XY width and height, and I'll add a separator here to be a new line. Okay, so our separator here is going to be a new line, and that's all. So when I rerun this, it will get printed in the terminal, and for that I'll change this image to soccer.jpg so that we can test this one as well. So let me save this and let me quickly rerun the code. And here we go. So it has done, is done. And over here you can see we have printed person. So it has detected person about 4 times. Now we have a lot of persons here. We also have a sports ball, and the confidence comes as a tensor and it's in a list form. So this is all the confidence for all the objects it has detected on the images. Then the bounding box information. So here are the bounding box information in this particular tensor. So let's view the result. So runs detect, that will be in the predict 2, and when I open this, so you can see it has detected a lot of persons, some people right here. It has been able to detect some people right here. So this model has performed good, and we have gotten that information. So that's what you need to know about object detection, localizing the human beings or people in an image, okay, an object in an image, and giving out vital information such as the bounding box, which is the box drawn out across the person, and then the class name, which is telling you, okay, this is a person, this is a sport ball, and then finally the confidence, okay, how sure are you that this thing you have detected is a person or not? So the confidence is, that's what you are seeing as 0.79 is a floating point, but when you convert it, it should be in percentage. Okay, so that's how you can do this on images. Now let's look at how you can do this on a video file. So real-time video file, how can we do this on a real-time video feed? Okay, so to do that is the same code, just get rid of this, and what you do here is to specify the source. Okay, and in this case you have to give it a camera source. So when we're learning about how to get our real-time web feed from the camera, I taught you have to just put the index of the camera. So 0 will automatically take your laptop webcam, but if you have a webcam attached to your computer, you can start from 1. So 1 will pick my webcam, and over here don't forget to also specify that show is equal to true. If you don't specify this, the code will be running, but the detection window will not open. Okay, you will not see anything, so make sure you specify that. And now we are going to run this code to see if it will open up my camera, and you guys will be able to see me, and let's see if we can detect some objects around my working space. And here we go, guys. So you can see me live in the webcam. You can see how my couch is being detected. I'm also detected as a person. I have a remote here. So let me raise it and let's see. So wow, so this has detected this as a remote. I also have a phone here, cell phone, which is very well detected as well. So you can see this object detection in real time, and this is just detecting everything so well. What other stuff can I try it out? So I have this small remote as well. Let me try this out. It's detecting it as a cell phone. That's not a cell phone. That should be a remote. I don't know why. Maybe it's in, yeah, cell phone, and it's sure about it. Now detecting as a laptop. So you can see this object detection in real time. And this is a nano version of the model. So we don't expect it to be that accurate, like compared to the, let's say, the small or the medium ones. Okay, so yeah, you can see this is running fully on my CPU, and this is detecting objects so well, guys. So yeah, guys, this is how you can do object detection in computer vision using ultralytics and some of these YOLO models. Okay, thanks for watching this particular one. I appreciate you guys so much for following this course up to this side of it. If you want to, let's say, use another YOLO model, let's say you want to use the newest YOLO 12, then you can just type YOLO 12 here. So you can use a whole lot of the YOLO models. So if you want to know the YOLO models, you can go to ultralytics.com And when you go to authorities, then you can find out the models which are there. So you can see for now there are a lot of models. So when you click on models, there are a lot of models you can use. Okay, a lot of models are there. So all you need is to specify the models available and you'll be able to run it. Okay, so thank you once again for following this course. Part 2 of this course will be coming, and let me know if you enjoyed this one. Let me know things you expect to see in the next part. This is the basic part. This is for beginners who are trying to get their hands dirty into computer vision. Thanks for watching this course, and I really appreciate you guys. I'll see you in the next course. Thanks for watching.